My name is Aditya Subramani, and I'm going to talk about case studies that I had done in my survey projects. I'm a third. I'm a second year at JIT, Johnson Institution of Technology College, Karamtapati, and I was given a case study about chain surveying, theodolite surveying, contouring, and plane table surveying. First, chain surveying. Chain survey is the simplest and oldest method of surveying used for small areas where the terrain is relatively flat and obstacles-free. It involves measuring linear distance using a chain or tape and plot the measured points directly on a field. This type of survey is used in a small area and a plain surface area, which don't have any major obstacles. The key feature of this chain surveying is simple equipments, chain or tape, ranging rods and arrows. And second point is stay sustainable for small and open areas, suitable for small and open areas. And next, relies heavily on linear measurements. Applications. Plotting boundaries of fields, small and next point is small scale engineering projects. Advantages is easy to perform and economical. Limitations. Accuracy reduced in undulating terrain or when obstacles exist. Time consuming for large areas. Second is theodolite surveying. Theodolite surveying is a precise and method used for measuring horizontal and vertical angles. Theodolite is an optical mission instrument mounted on a tripod that enables accurate angular measurement for detailed site surveys. This type of survey is used when you have to take a vertical angle or horizontal angle and to find the distance. So we can see the key features of this type of survey. Measures both horizontal and vertical angles, provides highly accuracy, used for tri- triangulation, traverse surveys, and setting out works. Applications: large scale topographic survey, construction layout like roads, bridges, and buildings, monitoring structural deformations. Advantages: high precision, useful in complex terrains. Sorry about that. Next is advantages: high precision and useful in complex terrains. Limitations: required skilled operators and more expensive and time consuming compared to chain survey. Next is contouring. Contouring involves the measurement and representation of the Earth's surface evaluation. Contour lines are curves that connect points of equal elevation and are used to dissipate the shape of the terrain ornament. Features: provides detailed topographical map, and contour intervals depends on map scale and terrains. Applications: site selection, reservoir or roads, and etc. Flood risk assessment. Flood risk assignment. Design of drainage system. Advantages: visual representation of slope and evaluation, useful for terrain analysis. Limitations: time consuming in rugged areas, required accurate level measurement instrument. Last but not the least, plane table surveying. Plane table surveying is a graphical method where observations and plotting of a survey point are performed simultaneously in the field using a drawing board fixed on a tripod. Key features: direct plotting on a sheet in the field using alignability Oh, I can't pronounce it. Sorry for the inconvenience. Um, ALIDAD for slide profiles, applications, small and medium scale surveys, and mapping of relatively small areas. Advantages: immediate graphical representation, simple and quick for small projects. Limitations: limited accuracy for large or uneven terrains affected by weather conditions. Now, we are going to see uh, the pre-survey steps before you start of the preparations. There are totally 7 points. First, recon concatenations and index sketch. Walk the path, note obstacles to your pond boundary, and pick a baseline along the longest straight edge. Draft a small sketch. Second point, fixed stations. Select well intervisible stations forming well conditioned triangles. Drive pigs, tags them ABCD, etc. Select scale and booking. Decide scale. Example 1 centimeter equal to 2 meter. Prepare a single line field book. Change the center line offset on sides. Next point, clear and range. Lightly clear vegetation along chain lines. Place ranging rods, come out, and check the intervisibility. Equipments check and calibration. Equipment check chain or tape, length verified, arrow spikes, mallet, ranging rod, crossstaff or optical square, plumb up, line range, field book, pencil, and chalk. Team roles and safety. Leader, follower, booker, and sign agreed PPE if needed. Tie or reference detail. Tie nearby permanent features. Electrical pole, cornerstone for future re-establishment. Second, we are going to see the second part of theodolite surveying. I mean, like, first question on theodolite surveying. Setting up the theodolite at station T. Tripod setup. Place tripod over the station peg, leg firmly pressed. Head roughly leveled. Instrument height comfortable. Unmounted instrument. Fix the theodolite on the head. Clamp lightly. Approximate centering. Use optical plummet or plumb bar to bring the instrument over the station mark. Adjust tripod legs to center. Rough leveling. With tripod leg, bring the circular bubble near center. These are these points which useful to set up the theodolite at any station. For case study on contouring of water reservoir site section. First question is significance of contour map in the object. The contour map turned out to be very important tool because it helps us understand the slope and gradient of the terrain, which was crucially in identifying a natural depression where the water could accumulate. Second, by reading the contours, we could estimate the storage capacity of the reservoir and also define suitable places for constructing the pond but or dam wall. Gave us insight into drainage platform. Example for which direction water would naturally flow in the site. Contour map is also indicated on accessibility to the site and possible road alignment for the future construction. Then in the case study of plain table surveying, the first question is on the case study of plain table surveying, the procedure or radiation method. We select central station inside the campus where the whole boundary was visible. The plain table was set up and oriented with respect to magnetic north. Second point, a point O was marked on the drawing sheet representing the instrument station. Using an alidad, we sign each boundary corner, say A, B, C, D, directly from O. Arrays were drawn on the sheet on the direction of each corner. Fifth, the distance from O to each corner were measured on the ground with tape and then scaled off along the corresponding section. Sixth point, after plotting all the points, we joined them to get the boundary of the campus. This method was quick and effective for our relative small areas.